Okay, so question number 13. Configuration for sulfur. Okay, so when writing out electron configurations, first we need to divide our periodic table, find it here, into different sections. So our first two rows is the S block, and then this green portion here is the P block. The middle transition metals is the D block. And finally, these last two rows, the lactanides and actinides, is the F block. And then we try to find sulfur on our periodic table. So it's right here, atomic number 16. And then starting from hydrogen, we move left to right across the periodic table, writing the row number and then the block letter. And then you'll notice that when we get to the D orbital, we write the row number -1. And when we get to the F block, we write the row number -2. So then let's start from hydrogen, and we write the row number, which is 1, the block letter, which is S, and then in the superscript, we show how many electrons are in that orbital. So there are 2 electrons in the 1s orbital. And then we move on to row number 2, 2s, another 2 electrons there. And then in the 2p orbital, it can house 6 electrons. And then moving on to the next row, we have 3s2. And then we get to 3p, which is where our sulfur is. And then we just count out 1, 2, 3, 4 electrons in this p orbital. And now this is the electron configuration of sulfur. And if we wanted to write the shorthand configuration, all we'd have to do is find the noble gas that comes before sulfur, which is neon, and we'd write it in square brackets, and then continue on writing the rest of the electron configuration as normal. So we write neon, and then 3s2, and 3p4. So this is also an accepted electron configuration for sulfur. Okay, so the junior tutor said that in writing the electron configuration of an element, we follow the Aufbau principle shown below, which states that the order of energy will dictate the order in which electrons are arranged in their orbitals. Therefore, the lowest energy will be occupied by electrons first. This is a simple way that we can also figure out the order of the electron configuration. Kind of write them all in the blocks like this, and then you go diagonally across and you get 1s, 2s, 2p, and then 3s, 3p, and then so on and so forth. Remember that each orbital can hold a different number of electrons. S orbital can hold a max of 2, the p can hold a max of 6, the d orbital can hold a max of 10, and the f orbital can hold a max of 14. And then they found the electron configuration to also be 1s2, 2s2, 2p6, 3s2, 3p4. So this solution is correct.